Good morning, everybody. First of all, I would like to introduce myself. I am Dr. Rama Prasad, qualified with the MSc PhD, specialization organic chemistry. I have 41 years of teaching experience, and mainly my teaching experience is in teaching chemistry intermediate level or +2 level. And I also taught for competitive exams like EAMCET, 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 JEE mains and advanced, and for NEET UG students. Now, today, I have chosen one topic belonging to organic chemistry at +2 level or at senior inter level. And the name of the topic is Carbonyl Compounds. As you all know, the carbonyl compounds contain a common group known as carbonyl group, C double bond O group. This is also known as carbonyl group. And these compounds containing carbonyl group are broadly divided into two categories. The first category consists of H and R in the place of these two bonds. And the second category consists of both alkyl groups, like this. These compounds are known as aldehydes. And these are known as ketones. These formulae can be briefly written like this: RCHO. It implies C double bond O is present, and one of the bonds is with hydrogen, and the other bond is with R, alkyl group. And for ketones, the short form is like this: RCOR. Here CO implies C double bond O. Thus, we can divide carbonyl compounds broadly into two categories, aldehydes and ketones. They have some properties in common because of the common functional group, that is C double bond O. Naturally, there are some differences also because of the differences in their structures. So it is better to study them comparatively, not to study them separately. So now I will present you a comparative study of these compounds, both in their preparation and properties. We are studying them because they are used in our daily life. Naturally, they are used in perfumes. Aldehydes and ketones are used in perfumes, in making plastics, and in making resins, and some fabrics, etc. Fabrics, etc. So, it is necessary to study them. And I give some of the important compounds which we find in nature as natural products. And they belong to this particular category of carbonyl compounds. This is known as cinnamaldehyde. Found in cinnamon bark. And this is known as vanillin. Found in vanilla beans. And this is known as camphor. You all know about camphor. So the camphor is a ketone. And this is an aldehyde, vanillin, that is found in vanillin beans. In cinnamon bark, we find cinnamaldehyde, and that is its structure. This is also a ketone, and it is known as muskone, found in musk deer, and it is a good perfume. It is used as a good perfume. So, like this, we use aldehydes and ketones as natural products in our daily life. This is a hormone known as a testosterone. That is also a ketone. And there is another hormone, progesterone, that is also a similar compound. So, it is not a waste to study about these carbonyl compounds because we can understand several topics in our daily life if you understand carbonyl compounds. That is the use of this chapter. Regarding their nomenclature, for aldehydes, at the end, Al will come, alkane Al. If you get Al at the end, it is IUPAC name of that one. I'll give you a few examples. HCHO. This is methanol. Al, not OL. If it is OL, it is alpha. And that is the simplest aldehyde because it has only one carbon. And IUPAC name is NEET. NEET means you know that for carbon number 1, AN. And that is IUPAC name. And its common name is formaldehyde. And 40% formaldehyde is known as formalin, which is used to store the dead bodies in laboratories. So that is an important compound. Similarly, acetaldehyde, CH3CHO. This is acetaldehyde. Acetaldehyde is common name, and EAN is IUPAC. If I write in brackets, it is a common name, and outside the brackets, I write IUPAC. Similarly, I will give you some more. CH3, CH, double bond, CH, CHO. This is protonaldehyde. That is common name. And if you want to write IUPAC name, you just give numbering 1, 2, 3, 4. So it is butene, 2-ene, 1. Because there are 4 carbons, it is butene. There is double bond between second and third carbon, so 2-ene and 1 Al. Al means aldehyde. So this is IUPAC name, whereas protonaldehyde is common name. Like that, these are some examples of aldehydes. Similarly, I will give you 1 or 2 examples of ketones also. Ketones, general IUPAC name is alkanone, and the first compound consists of 3 carbons. There is no compound with 1 or 2 carbons. Minimum 3 carbons must be there to write a ketone. And according to IUPAC nomenclature, this is prop because there are 3 carbons prop, and because there are only single bonds between carbon and carbon AN, propan, because it is a ketone at the end, ONE will come. So its IUPAC name is propanone, and common name is very famous, and it is acetone. Similarly, butanone, CH3, C double bond O, CH2, CH. This is butanone. And some diketones are also there. CH3, C double bond O, C double bond O, CH3. This is 2,3 butane diol. So since there are 2 carbonyl groups, it is di because it is a ketone ONE, diol. And it is a very famous compound. The buttery flavor in butter is due to this compound. The butter is having a buttery flavor because of this compound. So these are some examples of ketones. One should know how to write IUPAC names. There is some standard procedure. I think you all know how to write the IUPAC names. Common names you have to remember. There is no rule, specific rule for common names. You have to remember the common names. Now regarding isomerism in these compounds, there is chain isomerism in these compounds. You take any aldehyde, CH3, CH2, CH4, and ketone, CH3, CH, CH3, CH2, CH2, CH4, and CH3, CH2, CH3, CH4. Both are isomers. If you work out, they have common same formula. But in length of the chain, here there are 4 carbons. Whereas here in the longest chain, there are only 3 carbons. So these two belong to chain isomers. These are like best examples of chain isomers. So aldehydes and ketones have chain isomerism. Similarly, they have functional isomerism. There is functional isomerism. Functional isomers are different in functional groups, you know that. This is, say, butyrolidine. And here the functional group is aldehyde group. Here the functional group is carbonyl group or keto group. Because functional groups are different, these two belong to functional isomers. That is second kind of isomerism which we find in aldehydes and ketones. Next comes to metamerism. Say 1, 2, 3, 4, 5, like this. In this structure, there are 5 carbons, and C double bond O group is at this position. And its metamer is like this. So to the C double bond O group, on the other side there is only 1 carbon, and on this side there are 3 carbons. Whereas in its isomer, on this C double bond O group, there are 2 carbons on this side and 2 carbons on this side. And you know that such an isomerism is known as metamerism. They differ in the length of the carbon chain on either side of the function. Here you know that the function group is C double bond O. Here also it is C double bond O. 1 plus 3 carbons in this compound, 2 plus 2 carbons in this compound. So naturally they are metamers. And another important isomerism in carbonyl compounds is keto-enol tartamerism, a very famous isomerism that is called keto-enol tartamerism. Keto-enol tartamerism. I will give you an example. CH3, C double bond O, CH3. This is known as keto form. You can easily understand because there is keto group. It is a keto form. Now, if one of the hydrogens on this shifts here and this pi bond shifts here, we get this compound. This is known as enol form. As you all know that en refers to double bond, OL refers to alcohol. Because there is double bond and alcohol group, we call this as enol. And again, if this hydrogen shifts here, and if these pi bonds simultaneously shifts here, we get this. So these two forms, keto form and enol form, are interchangeable. That is the main difference between the other types of isomerism and the keto and alcoholism. Here the two isomers are interchangeable. There is an equilibrium between these two forms, and one form can convert into the other form because of this shifting of bonds. So that is the speciality of this keto and alcoholism, and that is found in this keto and alcoholism, in these carbonyl compounds. So that is regarding isomerism in carbonyl compounds. Now I will go to the preparation part of these compounds. Simultaneously, aldehydes and ketones can be prepared by these methods with some differences. I'll explain you them comparatively. The first method of preparation is from alcohols. Alcohols on mild oxidation give aldehydes or ketones. I'll explain you which kind of alcohol will give you aldehyde and which kind of alcohol will give you ketones. But alcohols on mild oxidation will give you aldehydes and ketones. You may ask this question: if it is a strong oxidation, what happens? If it is a strong oxidation, we get carboxylic acids. And that is of no use to prepare aldehydes and ketones. So I don't explain you this is strong oxidation because we are not getting aldehydes and ketones. I will explain you only this mild oxidation. So naturally you require the reagents which give mild oxidation and which give strong oxidation. Generally, strong oxidizing agents are acidified KMnO4 or acidified potassium dichromate. Because we should not do strong oxidation, we should not use these reagents. We have to use only mild oxidizing agents. Those mild oxidizing agents are PCC, PDC, and porous reagent, Jones reagent, like this. Now I'll explain you what is PCC. First of all, you have to know about reagents. Only after reagents, after knowing about reagents, you can understand the reaction. PCC is, its full form is pyridinium chlorochromate. Its structure is like this. This is pyridinium ion. And that positive ion is associated with the Cl minus ion. And there is CrO3 also. This is pyridinium ion, chlorochromate. This is the structure of the PCC. That is a mild oxide. Another one is PDC. PDC is pyridinium dichromate. Its structure is like this. This is pyridinium ion and this is dichromate ion. And the dichromate ion valence is 2. So pyridinium twice Cr2O7, that is its structure, and this is PDC. Next, porous reagent. This is also known as Collins reagent. It is obtained by mixing pyridine with chromium dioxide in dichloromethane solvent. This solvent is dichloromethane. That is Corres reagent or Collins reagent. Jones reagent is aqueous CrO3 in dilute H2S. So that is about the reagents. So far we have not studied the reactions. We are now trying to understand the reagents. All these are mild oxidizing agents. TCC, PDC, Jones reagent, Collins reagent, or Corres. Now I will go to the actual reaction. You take any primary alcohol or CH2OH. As you all know, if there is CH2OH at the end, it is a primary alcohol. Heat that with either PCC or PDC or Collins reagent or Jones reagent. All the reagents are not necessary. Any one of them is sufficient. Whichever is available, that can be used. But all these are mild oxidizing agents. These are mild oxidizing agents. So they give aldehydes. We get aldehyde, corresponding aldehyde. And you know that these are secondary aldehydes. Secondary alcohols on similar treatment, on similar reaction, will give ketones. Here one can understand that R and R may be same, maybe different alkyl groups. You can use same alkyl groups or different alkyl groups. We get corresponding ketones. That is the first method of preparation of aldehydes and ketones by using mild oxidation groups. Now the second method. Second method is from allyl alcohols or benzyl alcohols. Allylic alcohol means you know that there should be a double bond at alpha beta position. This is the aldehyde group. The carbon next to this aldehyde group is known as alpha. The next carbon is beta carbon. Because there is double bond between alpha and beta carbons, this is known as alpha beta unsaturated alpha. Also known as allylic alpha. If you use a particular oxidizing agent, double bond will not be oxidized. This is CH2O alpha. That changes to R. So double bond remains the same. Nothing will happen to double bond because of that reason. Only this alcohol part converts into aldehyde part. So naturally there is a method of preparation of aldehyde from allylic alcohol. Now you may ask, what is the reagent that is to be used? The reagent that is used is MnO2 in dichloromethane solvent. That solvent is to be used, and the oxidizing agent is manganese dioxide MnO2. By a similar reaction, benzyl alcohol CH2OH. This is benzyl alcohol. That gives benzaldehyde. And you cannot get them by using other oxidizing agents. These double bonds will remain same as they are, and we are getting aldehyde group in the place of alcohol group, and that is possible only if you use manganese dioxide in dichloromethane solvent. So this is another important method of preparing aldehydes and ketones. So the difference is obvious. Here we are using primary alcohols to get aldehydes, and we are using other alcohols to get ketones. The next one is open ion oxidation. This is a named reaction, named after a scientist, open ion. In organic chemistry, named reactions are very important. So one should remember such named reactions very carefully. In this also primary alcohol is treated with CH3 thrice O. It is also known as aluminium tertiary butoxide. In the presence of acetone, plus acetone is also to be used. Then we get aldehyde. Corresponding aldehyde. Corresponding aldehyde means the number of carbons present in this alcohol is the same as the number of carbons present in that aldehyde. That is the meaning of corresponding aldehyde. Plus we get isopropanol. See one important point here. An alcohol and a ketone are mixed in the reaction, and we are getting another aldehyde and alcohol. This alcohol we are getting from acetone. Isopropyl alcohol we get from acetone, whereas this primary alcohol gives aldehyde. That gives aldehyde. You may use cyclohexanone also in the place of acetone. Always you need not use acetone. You may use cyclohexanone, in which case you will get cyclohexanone. So this is another important reaction, and that is a new reaction. That is open-air reaction, very important. The reagent mainly consists of a ketone. This alcohol undergoes oxidation, whereas this ketone undergoes reduction. Simultaneous reduction and oxidation takes place. Thank you. Thank you for this.